Alright, hello everyone, welcome to this video. I'm Cubic. I'm uploading something. I would love to show you a thing that I've made. It's called CNet, stands for CubeNet. So this is basically networking, but in scrap mechanic. So, what I've done is, so far, is not a lot. It's just the CNet adapter. That's this box that I have here, and it's the hub. So the CNet adapter is called CNet 1001. And the hub is called CNet 2000. The naming convention is interesting. The first digit is the type of the device. So we have the adapter, which is the first type. We have the hub, which is the second type. We have the third type, which is a switch. Fourth type, which is the router. Then we have the second digit. It's just reserved. Third digit and fourth digits are the version. So currently I have CNet 1001. So it's a CNet adapter version 01. So yeah, that's a really minor change. I'm not sure if it was worth updating it to 1001, but it doesn't matter. Okay, I'm gonna finally actually show you what this thing can do. So why am I using hub? Some people may know that hubs are complete trash. I'll say that even though they are trash in terms of doing stuff, in terms of working, they are very effective at testing stuff because there is basically no logic involved here. Like, look at this thing. Okay, I'm gonna actually spawn a new one. Like, look at this thing. Do you see any complex logic here? No, because it's literally just sending the data to all other ports. It's ridiculously simple. So, yeah, that's why I'm using it. So, this is the input, this is the output. Output goes to the adapter, to the dark magenta one. And the input, it goes from this hub. Light magenta goes to this light magenta input. So, let me show you it actually transferring the data. So I'm gonna show that this thing has, I call it CNP because it's not really an IP address. It's just like an address. It's CNet protocol, whatever. I don't know how I'm gonna call it. It's an address. So this is the first address, this is the second one, and this is the third one. That hopefully makes sense. So we're going to climb on this thing. And I've already prepared the mighty button, which will transfer this beautiful image. So the cool thing about the CNet is that we can transfer, theoretically, up to 256 bytes of data. So, and we don't send all 256, like it's not fixed length. We'll transfer just 7 bytes currently. So it's 1, 2, 3, 4, 5, 6, 7. 7 bytes. We're going to transfer just that. We're not going to transfer any more. So yeah, we can set the packet size. For now it's manual. Yeah, we can set this is the packet size and this is the IP to which, or address to which we're sending the data, right? So let's actually send it. So let's send it to second IP address. Yeah, let's send it to this router. Sorry, adapter. Sending it. Yep, the data is already transferred. I'm actually gonna show you something. I think that would be interesting to see. First, I'm gonna demonstrate that it actually have transferred the data. Here we go. Here it is. And I'm also gonna show you a funny thing. I'm gonna connect this oscilloscope Yeah, it will block the sunlight, but who cares? And we're gonna check out one of the output ports. This one. Or wait, no, this one. This is the output. Yeah, light magenta output here. For some reason, I'll change the colors because they don't make sense. Okay, we're gonna connect light magenta to this here. And we're basically gonna see the data that is being transferred through our network. So I think that would be interesting to see. 4th, 5th, 6th, 7th, and 8th. Okay, nice. So now I'm going to hook this button directly to start logging the signal, and we're just gonna transfer it. Let's transfer it to a third IP address. So currently we have here this smiley face, and so we're going to transfer it to here. Let's actually do that. I think it was at NOR gate, so I think, whatever. So let's transfer. You saw that it blinked there, and let's see. And here we go. Here's how the actual packet looks like. So here we have the sync pulse. It's just all ones. Then we have a 2-tick delay. And then we have the data for our packet. So this is the IP address. So this is the destination IP address. This is the source IP address. And this is the packet length. And this is the packet itself. So you can see it's quite nice. It's really fast, I think. Yeah, theoretically it could take quite a while to actually transfer the data, but doesn't matter. So yeah, pretty neat, I think. And let's actually check out our third router. And yeah, as you can see, here's the data. Let's now try to transfer the data from the third, not the router, but adapter, excuse me. Let's try to just, I don't know, do something like that. It's XOR memory, by the way. So I've exposed it, so it could be kind of more fun, I guess. So okay, here we go. Here's a messed up smiley face. So we're going to transfer to, let's see, let's transfer data to first IP address, just address, and the packet size. Let's actually test this. Let's go with 4. So the minimal packet size is 4. We cannot transfer 3. It shouldn't do anything theoretically, although it will clear the memory. I don't think I have fixed it. So I think it will clear the memory here, which is a bummer, but I'll fix that. So yeah, you can see, actually it have cleared the data for both of those. Wow. Yeah, that's unfortunate. Really should fix that. But yeah, it's an incorrect packet size, so it just messes up everything. Oh wow, that's not good. Why did that happen? Okay, ignore that. I don't know how did it get stuck. I honestly have no idea how it just got stuck like that. Huh, weird. Okay, I'll debug that later. So let's try transferring the data to first IP address. What is going on with this CNet adapter? This one does seem to work fine. This one doesn't seem to work fine. That's weird. Well, okay. And you can see that we have transferred some part of the data. We have transferred exactly 4 bytes. But we haven't transferred all of the bytes. And that's pretty cool in my opinion. Let's actually transfer now all 7 bytes. I mean, we can transfer all of the data that we have, like 32 bits. Let's actually try that. I haven't tried that yet, so that would be interesting. Yeah, to have transferred the data. It's pretty quick. Yeah, you can't see that it have transferred 32 bytes, because those are 32 empty bytes. But you can see that it did transfer the data. Let's try doing the same here. Let's just do some random garbage data here. Just gonna do that. There we go. And let's transfer this garbage to this one. So we're just gonna put on 32 and we're transferring to third router adapter. Here we go. As you can see, it have accepted here, it have cleared here. I shall fix that. But as you can see, the data here is here. Makes sense. And let's transfer from here now to there. And let's maybe change it even more. And transfer it to first. Have I transferred? Yeah, I have. Whoops. Well, you've already seen that it have transferred. It have indeed transferred the data, like as you can see. So yeah, that's pretty fun, I think. Let's actually try to log all of that. So third 7. Let's go with that. I don't think I'll be able to capture the entire signal, but it doesn't matter. Yeah, and here, as you can see, here is the sync pulse, delay, destination IP address, source IP address, just address, excuse me, and then the length of the packet, and then the packet itself. It probably have gone somewhere, like it's probably longer than the oscilloscope can capture, but it doesn't matter. So yeah, that's that. You can see it didn't transfer all of it, but it have transferred 15 bytes theoretically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, nice and easy. 15 bytes. Yeah, that's about it. That's all I wanted to really show. I think that is pretty neat. In the future, I'm planning to, well, first of all, fix all the weird glitches with those CNet adapters. Don't want any bugs in them, because I am planning to do something with them. And planning to make a switch. I don't plan on creating a router, however, because I don't think I'll be making anything with routers. I don't think I need to route stuff. Although maybe something like a virtual local area networks, VLANs, but I don't want to do those. That requires too much computing power, which Scrap Mechanic really doesn't have. I could use routers to communicate between other networks, I guess, and create something like a NAT, but don't want to do that. It's pain in the ass. I have spent enough time on this thing already, even though it doesn't seem too complex. Well, this is just memory, so it's just a giant hunk of stuff, of logic. And this logic, it's not complex, but it have required me to think for quite a while for some reason. Like 8 hours in total, maybe even more, which is honestly depressing when you think about it, but it doesn't matter. Funny thing you could do, I think, is you could probably... Anyway, yeah, you could probably do some IP spoofing, theoretically, but I mean, doesn't matter, really. So yeah. Switches, I'll be making manually configured switches, so you'll have to configure them manually, obviously, because I don't want to have to make switches which are configured automatically when you connect an adapter to it, because it seems like too much work. So am I planning to do something like lognet or some stuff like that? So am I going to transfer data with spot guns? I'll say that probably not. If I will, I'll definitely make an adapter for that. And it will be something like 5000 series or something. Um, so yeah, SpotNet adapter, some whatever stuff. Well, not SpotNet, just Spot adapter, because SpotNet is apparently also an internet inscribe mechanic. Yeah, that idea isn't new. Anyway, uh, you can find all of this stuff in the workshop. You can just type CNet 2000, CNet 1001, you'll find it, I'm sure. So yeah, that's about it. Thank you for watching it. Bye.